Namaskaram. In this video, we will cover all these types of matrices. Don't be afraid, you will understand all these matrices within one revision since they are so simple. So let's start with row matrix. A matrix having only one row is known as row matrix. Remember the mnemonic which we have learned in first part. RH and CV. R stands for row and H stands for horizontally. C stands for column, V stands for vertically. Therefore, a row means when we lay some elements horizontally and column means when we lay some elements vertically. This is all about row matrix. Similarly, a column matrix is which have only one column is known as column matrix. Now what about this matrix? Is it a row matrix or a column matrix? The answer is this is both, also known as singleton matrix. Now answer its order in the comment. What is a rectangular matrix? A matrix of order m by n with m is not equals to n is known as rectangular matrix. Similar as we see rectangle having length and breadth which are not equal to each other. And a matrix of order 2 by 3, 4 by 5, 2 by 1 is a rectangular matrix as its dimensions are not equal to each other. Let's see. D is equals to 1, 0, 9, 11, 13, 15. This is a rectangular matrix. As we can see, its order is 2 by 3. Square matrix. A matrix of order n by n is a square matrix. That means a matrix with equal number of rows and equal number of columns is a square matrix. All matrices of order 1 by 1, 2 by 2, 3 by 3, 4 by 4 and more are square matrices. This matrix is a square matrix as it has two rows and two columns. Diagonal matrix. Do you remember the terms we learned in the previous video? Yes, because diagonal word comes now. A square matrix in which all the non-diagonal elements are 0 is known as a diagonal matrix. This example is for diagonal matrix. -1, 3, 7 are diagonal elements, but the non-diagonal elements are 0. Therefore, this is a diagonal matrix. Another example, G is equals to this. A diagonal matrix can briefly be written as like this, writing all the diagonal elements within the braces and abbreviation of diagonal word outside the braces. Scalar matrix, a diagonal matrix in which all the diagonal elements are equal. Now carefully see the word diagonal matrix. Yes, a scalar matrix should be a diagonal matrix first. All diagonal elements equal to a same scalar value here. See this example. Another example. Identity matrix, a square matrix in which all of its diagonal elements are unity means 1 and no non-diagonal elements are 0. Means a square matrix. Yes, identity matrix should be a square matrix, having all its non-diagonal elements as 0 and diagonal elements as 1, denoted as I2 and I3, where I means an identity matrix of 1 by 1, I2 means an identity matrix of order 2 by 2 like this. Similarly, I3 means an identity matrix of order 3 by 3. Now the question which arises that why is it called an identity matrix? You will understand this in upcoming lectures, so stay tuned. Zero matrix. As its name suggests, this is a matrix whose all elements are 0. Therefore, a matrix in which each of its elements is 0 is known as zero matrix, also known as null matrix. We generally denote it as like this. Upper triangular matrix, a matrix in which all the elements below the principal diagonal are 0. We know principal diagonal is considered from upper left to the right bottom. So the elements below the principal diagonal are 0 here. Thus, this matrix is a upper triangular matrix. Just remember, a upper triangle full of elements. Lower triangular matrix, a matrix in which all the elements above the principal diagonal are 0. So this is the opposite of upper triangular matrix. A matrix whose elements above the principal diagonal are 0 is known as lower triangular matrix. So for this you should remember a lower triangle full of elements.